Algebra 2, and welcome to Lesson 2.3. We are going to be applying today some applications of inequalities. Some things to note here. Right off the bat, just be aware of different terminologies. Whenever we say x is at least a, that means it's greater than or equal to. No less than is greater than or equal to. And these are just great things to just kind of have in the back of your mind as we dissect these problems, okay? The problems themselves, they do make you think a little bit, so put your thinking caps on, and let's just dive on in. So a coin jar contains 5 more dimes than nickels, 2 less quarters than nickels. If the total value of the coins in the jar is at least $2, at least how many dimes must be in the jar? Okay, doesn't look like a lot, but really, there is quite a lot going on here. So, at least how many dimes must be in the jar? So we see at least. Dimes is what we want to solve for, and we have some other information here. I always like to look at word problems and think, what are we trying to solve for? And the answer is at least how many dimes must be in the jar. First thing we know, okay? We know we have a coin jar, okay? What's in that jar? We know that there are dimes. So dimes plus nickels plus quarters, we know amongst those three things it must be greater than or equal to $2. Okay, just the fact that, okay, if the total value of these particular coins is at least 2, that's what it is. Now I know there's pennies, but it doesn't talk about pennies, so that's all we're concerned with. Now, let's just think about monetary-wise. A dime is 0.1 of a dollar. A nickel is 0.05 of a dollar. And a quarter is 0.25 of a dollar. That will help us out in the near future. Greater than or equal to 2. Okay, you can drop to 0, 0. That's okay. All right, so with that in mind, now comes the more challenging part. So we want to solve for D. That's what we want to solve for. The problem is we have these other letters of the alphabet holding us back. Okay, N and Q. So what we actually want to do is we want to turn N, the number of nickels, into a statement about dimes. So nickels, we want to turn into dimes. Haha, if only we could do that with real money. Anyway, so here's how we go about that. Let's just look at our statement. We have 5 more dimes than nickels. Okay, so let's think about this. That means if I have 10 dimes, that means I have 5 nickels. If I have 15 dimes, I have 10 nickels. If I have 8 dimes, that means I must have 3 nickels. If I have the letter or just the variable D, number of dimes, in order to make that nickels, what do? We subtract 5. So D minus 5 is equal to N. That is what nickels is in terms of dimes. Okay, so we're going to keep that and use that in a little bit. So that's going to help us out. The next bit is quarters. Now we want to turn quarters into a statement about dimes. So let's think here first. First, we're actually going to turn it into a statement about nickels. So we have 2 less quarters than nickels. So let's think here. If I have 12 nickels, that means I have 10 quarters. If I have 10 nickels, that means I have 8 quarters. Say I have any n number of nickels. What I do is I'm subtracting 2 in order to equal the number of quarters. Okay? So we turn quarters into a statement about nickels. Now the next thing we can do is, well, we actually know about nickels, so let's just substitute that in there. So really, we have the number of dimes minus 5, and if we subtract 2 more, that equals quarters. So quarters is really D minus 7 is equal to Q. Okay, if that part is like, what? Just take a breath. It'll be okay. Go back. Think about it and be like, oh, okay, let's just keep going, okay? It'll be all right. We'll do some more problems with these, or I'll give you some practice. Now that was the hard part. The easy part is just substituting everything in. Okay, so 0.1d plus 0.05n. N we're actually going to replace with our new and improved d minus 5. Okay, because that's what it is. Plus 0.25 times what is quarters in terms of nickels. That's d minus 7. And we know that's greater than or equal to 2. Okay, so the colors, hopefully you see, I'm trying to use those to represent substitution. From here, just distribute and solve. It's not all that bad. 0.1d plus 0.05d, so let's just distribute. 0.05 times 5 is 0.25. Plus 0.25d minus 0.25 times 7, 1.75, greater than or equal to 2. Combine our like terms. Okay, 0.1 plus 0.05 plus 0.25 is 0.4d. If we go ahead and add the 0.25 to the right and add the 1.75 to the right, you should get greater than or equal to 4. 2 plus 1.75 plus 25 is 4. Then we just divide. And hey, we get d is greater than or equal to 10 dimes. How about that? Okay, you might get a decimal at some point in which you just round up. So I have at least 10 dimes in the bank account. Pat yourself on the back. That is no simple walk in the park, but you got it. Also, just to be aware, you must show work on these problems. No guessing and checking. Okay, you are honors students. So please just get used to demonstrating your understanding. So nice job with that one. Next example. Next example I like to think is actually a little easier. Find the smallest set of 3 consecutive even whole numbers whose sum is greater than twice the middle integer or whole number. Okay. That's what it means to say. Oh man, okay, so I don't even see any numbers in this one, but we're just going to need to think, okay? The first thing to recognize, here's a little math trick. Even whole numbers, or even integers. To represent an even integer, those are numbers like what? 2, 4, 6, 8, 10, so forth. Or -2, -4, those integers at least. The little trick with this is any integer can be represented by 2 times some number x, and that's it. 2x. If you take 2 times any number, you get an even integer. So let's say our first integer, or whole number, is 2x. Okay? The next number, so plus the second whole number, or integer in this case, so this should be whole number, plus third whole number. And we know that needs to be greater than or equal to 2 times the second whole number. So that might be helpful to represent. If we add the first whole number plus the second whole number plus the third, that must be greater than twice the second whole number. First whole number is 2x. Well, the next one in line, okay, well, we wouldn't want to add 1 to that. We want to jump 2 spots. So if we take 2x plus 2, what in the world? Come on. 2x plus 2, that's the second whole number. The third whole number would be, even whole number, would be 2x plus 4. And that must be greater than or equal to 2 times the second one, which is 2x plus 2. Okay, second, this pen is driving me nuts. Third number and first number. Okay. Once you kind of get past that, thinking it's not bad at all, let's just add our like terms on the left here. 2x, 2x, 2x is 6x plus 6 is greater than or equal to 4x plus 4. I just distributed and went from there. Let's solve then. So 6 and 4, that's 2x, must be greater than or equal to negative 2. And if we divide, we have x is greater than or equal to negative 1. Now that's, if you notice, that is not the answer. That's not a whole number, and that's not an integer, or it's not even. What you have to do, though, is now think. So if x has to be greater than negative 1, our first whole number is 2x. Okay? So the first number must be 2x, or 2 times negative 1, which is negative 2. Okay? So we know that that would not be a part of the first set. So the negative 2, 0, 2 would not work. Okay? Because they're not all whole numbers. So we try the next one. Let's try the first number being 2 times, well, x must be greater than or equal to negative 1. So we tried negative 1. Let's try 0, 0. Okay. Well, 2 times 0 is 0. That is a whole number. The second number is 2 times 0 plus 2. Well, that is, in this case, 2. And the third is 2 times 0 plus 4, or 4. What we need to do now is check to see that the sum, just check to see if it works. So 0 plus 2 plus 4 is 6. And we want to know, is that greater than or equal to 2 times the middle number? Well, 2 times 2 is 4. Okay? So there are actually many other sets that this will work for. As long as x is greater than or equal to negative 1, and you go through this process to check. So that's the smallest set, 3 consecutive even whole numbers. For example, let's say it said odd numbers. Those are represented by 2x plus 1. Those actually give you all the odd numbers. So some thinking problems with that. Okay? The last particular problem, a poster has a length 3 times its width. To fit in a frame, 2 centimeters is cut off to each side. The resulting perimeter must be at most, 44 centimeters. What are the largest possible dimensions? So let's just imagine we have a poster, length times width, and start by just kind of writing down everything we have. We know perimeter. Okay, perimeter we know is 2 times the length plus 2 times the width. Okay, what else is something we know? Have a length that is 3 times its width. So length is 3w. Substitute that in. That means our perimeter is equal to 2 times 3w plus 2w. Okay, and what are we doing to each of those sides? We are cutting 2 centimeters off from each side. All right, so that means our perimeter now is 2 times a 3w minus 2. When we cut it, let's draw scissors here. Nice. Plus 2 times 3w minus 2. Sorry, just 2 times w minus 2. And that is our new perimeter. Now, last thing we need to do is at most 44. So the perimeter must be at most 44. So 44 is greater than or equal to 2 times 3w minus 2 plus 2 times w minus 2. From there, just shake and bake. 44 is greater than or equal to 6w minus 4 plus 2w minus 4. Let's add like terms. 8w minus 8 is greater than 44. Or 44 is greater than that. Add, so 44 plus 8. 52. Greater than or equal to 8w, divide by 8, divide by 8. And we know that the width must be underneath 6.5. So that's our width, 6.5. We know the length is 3 times that. It is asking for the dimensions, so this must be 19.5 since it's 3 times. So please, again, notice what are the largest possible dimensions. Don't just finish here. Finish it out. We know the length is 3 times 6.5, which is 19.5. Okay, boom. Those are the types of word problems to expect. If you are scared, I mean, you should respect the math. Just respect that this is possible, that all this can be done, and you too can do it. The 3 following problems, the practice problems, they are all similar to each of the corresponding or respective problems. So coin collection, 415, you're going to do it very similarly. Number 2, smallest selection of 3 consecutive odd integers. Remember, our odd integers start at 2x plus 1, such that the sum of them is greater than twice the largest integer. And a poster has a width 2.5 times the length in order to fit into a frame. So try those out. I'll put the answers up. We'll go over those Monday or the next day in class. And nice job, guys. Again, don't fret. I'm glad you watched those. If I see all of these done, I will give you Dvorsky dollars, of course, for your efforts. Thanks, guys. Good job.